Section 2.3 is going to go over a lot of the information that we're going to need to be able to get off of a graph. And Bilal's reminding me we should double check the sound. I do believe we have, yeah, we're good on the sound. So we'll start with problem number 8 here. And they ask you for this function g to find certain values. So in particular, they're looking for g of -4, g of -2, 0, 2, and 4. Keep in mind that g of x is just some notation. It's really taking the place of y. So what they're essentially asking us to do is to make a t-table and to find certain values of y given a value of x. So g of x, and those values are -4, -2, 0, 2, and 4. And we're going to refer to the graph right here. So we'll start at g of -4. We're looking for the y value there. What's the y value at g of -4? 3. Good deal. And then at -2, we're at a height of 2. Right? So -2 and 2. How about 0? What's the y coordinate at 0? -2. Down here. Good. So -2. 2 more. G of 2. 1. Now be careful here. This dot is solid here and hollow here. That means we're going to evaluate the function down here, not up here. So a 1. And last but not least, g of 4 is 0. So there's all of our y values for the associated x values. Speaking of x values, it's asking us for the domain here. We want to find the domain and range. The domain is associated with which values? X values. So that would be from here to here. So in this case, what's the domain? Good. The domain is -4 to 4. Now the important question is, are we going to include the endpoints or no? Should we use brackets or parentheses? Brackets, because this graph does exist at -4, so I'll use a bracket here. And likewise, there's a solid dot here, so I'll use a bracket there. There's your domain. So this is part B. Let's take a look at the range. The range is the y values. So the y values, I'd appreciate you list it from lowest to highest. What would the y values be? Good, -2 to 3. So -2 to 3, and again, brackets because the graph does exist at these points. Notice it doesn't exist here, but it does exist here. So it does have a value at 3. Let's keep going. In fact, my last comment is really relevant to this next part. Part C, it says, find the values of x for which g of x equals 3. Now, effectively, that's asking you for where y equals 3. So where are the y coordinates equal to 3? For what x coordinates? Yeah, you have to kind of look at it a little bit, right? Certainly it happens at -4, but how come I can't list 2? Yeah, it's because it's hollow. Yeah, it doesn't really exist there. So there's just one answer to this, and that's for part C, x equals -4. If that was filled in, we'd also be able to put a 2 there as well. So far, so good? First 3 of these? Yes? Okay. Let's try some more here. Estimate the values for which g of x is less than or equal to 0. All right. Well, that's going to be starting here where this graph dips below the x-axis. So about there. In terms of the values for which g of x is less than or equal to 0, they're looking for the x values. So what should I put there? What should I list as my answer for part D? Well, where does it start? Along the x-axis, it starts at -1 up to 2. Now, I got a good question in my morning class, and that is, well, is that going to be brackets or parentheses? Well, we're looking for where this is less than or equal to 0, and it looks like at -1, looks like the value is actually equal to 0. So would that be true at -1? Yeah. So I want to include that, and I'll include that with a bracket. Likewise, over here, the other end of this, I'll also include that. You know, actually, yeah, I was looking at this really carefully, and if I look at it really carefully, actually it isn't that. It shouldn't go all the way up to 2, should it? It should go a little bit less than 2. So, a little Photoshop there. Let's not go quite to 2. What do you think looks a little bit more reasonable than 2? 1.75, 1.8, somewhere in there. But it shouldn't actually go up to 2, because 2 would be right there. And really it crosses the x-axis at a point a little bit to the left of 2. Now that's not very clear from this graph. Certainly if I was to give you a test question, I'd make it much more clear. I don't want you to have to guess. Last but not least, part E asks us for the net change in the function between -1 and 2. So at x equal -1, what's the value of the function? 0. The net change is just going to be the difference in the y coordinates. So really it's going to be g of 2 minus g of -1. So g of 2, what's the value of the function at 2? 1. Minus 0 gives you a net change of 0. So the function actually does a lot of things, right? It goes down, then back up. But the net change, well, you started out at 0 and you ended up at 1. So that's your net change. Yes. Net change is 1. Yep. But do you see that though? You just the gain from here to here. Yeah. Now later in section 2.4 we're going to go over the average rate of change. So we're going to take that net change and divide it by the length of the interval over which that net change occurs. Essentially what you're going to get is the slope. That's what's going to be in section 2.4 is the slope. But since we're not dividing by that distance there, it's just the net change. Anything else on problem number 8? Let's start problem number 10. This time we've got two graphs, g of x and f of x. And the first question is, which is larger, f of 6 or g of 6? Yeah, if we look at our graph here, this is the graph for g. And, well, which one's larger, f of 6 or g of 6? Let's see. Did I miss in that one? G. Looks like f of 6 to me, right? Yeah, f of 6. F of, G of 6. Oh wait, I'm looking too far. Let's see. 1, 3, 5, 7. All right, so g of 6. Yeah, here we go. I was looking at the end here. That would be f of 8 and g of 8. So at 6, yeah, g of 6 is bigger. How about at 3? Which one's bigger at 3? F of 3 is bigger. Now, what special thing is going to happen when f of x equals g of x? Yeah, they're going to intersect. And they're going to intersect at 3 different points. Here, here, and here. So what are the values for which f of x equals g of x? Yeah, 2, 5, and 7. So it's handy to have those around, 2, 5, and 7. Part D asks us to find the values for which f of x is greater than or equal to g of x. So that's going to be some intervals between in and around 2, 5, and 7. So I want g of x to be greater than f of x, greater than or equal to f of x. So that's going to be in this little interval right here, between 1 and 2. And then f of x is bigger than g of x until we get to 5. And between 5 and 7, let's see, between 5 and 7, things flip-flop. G of x is bigger than f of x again. As far as your answer is concerned, we have to answer this in interval notation. So we've got two intervals. Let's take a look at the first one. So for the first one here, that's going to be 1 to 2. Union, the second one's going to be 5 to 7. The big question is brackets or parentheses. Brackets. Good. Thank you. Brackets. Because we're including this. It's a greater than or equal to, and at the endpoints, they're equal to. So a bracket here, and a bracket here, bracket here, bracket here. So we're looking good. The last one's a little bit tricky. Let's see if we can't figure out the last one. This time we want f of x to be greater than g of x. And I've kind of covered it up a little bit, but it's just a greater than. It's not a greater than or equal to. So let's work on that one. That's going to happen here in this interval. And here in this interval. So again, we got to be a little bit careful with the brackets versus parentheses stuff. In this interval, what do I want to include? 2 and 5 with parentheses. Okay. Union. 7 and 8. But like I said, we have to be a little bit more careful on this one because there's something a little bit subtle about this last part here. Well, right here, they're actually equal. So, Lily, what should we do on the left-hand endpoint and the right-hand endpoint of this in terms of brackets and parentheses? Yeah, for the 7 and the 8. Well, we'll do a parenthesis on the 7 because here they're equal, and that's not going to make this true. So parenthesis here. But what happens at the 8? Yeah, bracket, because g of x is smaller than f of x at that point. So we can include what happens at the 8. The difference is that here they're equal, so we have to throw that one out. But here we don't. We don't have to throw that one out. So we can include the 8 there. All right, good deal. Anything else on problem number 10 there? We're looking okay with that one? Megan, does that look okay? Yeah, Dwayne? What makes it a bracket in D is that we're looking for a less than or equal to. And at these points where the graphs cross each other, they're actually equal to. And you can include those because we're looking for something less than or equal to g of x. So you can include those. If this was a less than, then, you know, f at, say, 2 wouldn't be less than g of 2. They'd be equal. So I couldn't include that. It wouldn't make that true. So that's why we can include it here with the brackets, but we exclude it here with the parentheses. Anything else on problem 10? Let's move over and talk about increasing and decreasing functions. And I guess what I like about increasing and decreasing functions is that at least their names make sense. A lot of times, some things in math, you look at it and go, what do you mean? Well, increasing and decreasing functions are actually appropriately named. Let's look at it in the book on page 174 real quick. You don't have to turn to it. I'll turn to it for us. If, as you move from left to right, the function is getting bigger, then it's an increasing function. On the other hand, if as you move from left to right, the function is getting smaller, then it's a decreasing function. The big thing you have to keep in mind is how you discuss increasing and decreasing functions. It's a matter of talking about it in terms of intervals along the x-axis. You're not going to talk about the y-coordinates. You're just going to say, oh, it's increasing from x1 to x2, whatever those happen to be. So let's look at problem 32 then, and remind ourselves a little bit about domain and range before we look at increasing and decreasing functions. Domain was which coordinate for your function? X-coordinate. So in this case, the x-coordinates go from here to here. So go ahead. Somebody said it. -2 to 3. Should you use brackets or parentheses? Brackets. Good. So brackets here. And then on the y-axis, something similar is going to happen as we look at the range. And the range is same thing, right? -2 to 3 for the range. Now let's get around to increasing and decreasing. As far as the first part of this function is concerned, what's happening between here and here? What's happening with the function? It's decreasing. So from here to here, the function is decreasing. And you describe that with the interval -2 to 0. Now I'm going to do something nice for you guys. We're going to keep this really simple. All your answers for increasing and decreasing are going to be with parentheses. So we don't have to worry about bracket or parentheses. To figure out what's happening at a particular point, you need calculus. And we don't have that yet. So we're just going to keep it real simple and use parentheses for all these answers on increasing and decreasing. After I get to 0, what happens to the function? Starts increasing. So from here to where? Where does it stop increasing? Yeah, to 1. Now it goes up to 3, but remember 3 is the y-coordinate. That's not going to be part of your answer. You're just going to deal with the x-coordinate. So from 0 to 1, it's increasing. Then what happens? It starts decreasing. 1, 2, 3. All right. Nice. So there's your domain and range and where it's increasing and decreasing. Are you guys ready to try one? Try number 34. Anything on 32 before I move over to problem 34? Give you a chance to do it. Dwayne? All right, so as I move to the right here, what's happening to the function? Which direction is it trending? Is it trending up or trending down? It's trending down. So as you move from left to right, if the function is trending down, then it's decreasing. What's happening next? After I get to 0, what happens to the function, Dwayne? It goes up. And it goes up until I get to this point, right? That's where it tops out. So in this interval from 0 to 1, that's where the function's increasing. And that's what you talk about when you're discussing increasing and decreasing is the x values. So for x equals 0 to x equals 1, in that interval right here, that's where your function is increasing. Then what happens? Then it gets up here to this point, and then what happens to the function, Wayne? It goes down, which is another way of saying it's decreasing. And it's decreasing in this interval for x's, 1 to 2. Yeah, you just do the x-coordinates. In fact, every now and then I get students who give me, an answer that I regard as everything but the kitchen sink. They go, oh, it's increasing from 0, -2 to 1 and 3. So they're giving me everything. And I really am not a fan of that. It's most appropriate just to talk about the x-coordinates. So that'd be from 0 to 1. All right? So good question. Appreciate that. You probably saved somebody a couple points on their exam. Problem 34. It's up to you. Give that one a shot. Determine the domain and range and where it's increasing and decreasing. And pause video here. Give you a chance at home to work on that if you'd like. What's that? Yeah, please, go ahead. I guess it's tough to tell. In my morning class, I kind of assume that one's filled in. Does that look filled in to you? Yeah, let's assume that it's filled in. And likewise with that one. Let's assume that they're both filled in. So, if that's the case, then there's no gaps that I see. The domain should stretch from here to here. So that should be your domain. And then likewise, your range is going to stretch from down here up to here. So George, what did you get for the domain then, please? Perfect. -2 to 2 in brackets. Good. And let's see, who else? Tierney. Good. Same thing for the range. -2 to 2. All right. Good. And again, keep in mind you're answering in intervals. And please go from lowest to highest, left to right, or bottom to top when you're talking about domain and range. I get a little uncomfortable with 2 to -2. So let's avoid that issue by getting it right. What's happening with the function first? It's decreasing. So in this little interval right there, from -2 to -1, it's decreasing. Then what happens? Yeah. After that, it's increasing from where to where? -1 to 1, and then it starts decreasing again from 1 to 2. So how are we looking with that one? Okay. Let's introduce another little notion into our work with increasing and decreasing, that kind of stuff. You know what? Let me make a quick detour. Let's play around with some graphs and other things like that on Desmos and on our graphic calculator. Let's take a look at problem number 20. just to kind of continue with domain and range. And let's look at domain in a couple different ways. In problem 20, f of x is the square root of x plus 20. Now the domain is your x coordinates that you can put into a function. But there's some x values that you can put in here that would create a problem. The problem we want to avoid is what in this case? Yeah, negative under the radical. We want to guarantee that what's under the radical is positive. So to do that, we want to make sure that x plus 2 is greater than or equal to 0. So that's going to be our domain. If that's our domain, well, that's equivalent to x is greater than or equal to negative 2. Now your range is a little bit more challenging to see when you're talking about doing this kind of algebraically. You can't. It's not that easy. So let's do it on you want to do it on Desmos or the graphing calculator? Graphing calculator? All right. Since we're going to be using the graphing calculator the most on exams anyways, let's go to our graphing calculator. Hit the y equals key. Clear out anything that you may have there. Square root key is down on the left-hand side. You have to hit the second key, then the square root key. And then type in x plus 2. Now for a window, I want something a little bit wider, a little bit above and below what I need. So let me set up my window this way. Let's go from, we use what we've got here so far. Negative 3 to 3 on the x-axis. On the y-axis, I'm guessing we don't need to go down to negative 7, so let's go to negative 1 and up to 3. It should be a reasonable window. It should fit pretty nicely. And what we should see when we graph this is a function that kind of tails off to the right. Something like that. Now, it actually does touch the x-axis here at negative 2. You can see that if you hit the trace key. If you hit the trace key and type in negative 2, it actually puts a cursor right there at negative 2 for x and 0 for y. So you can see that despite what it looks like here, even though it's not perfect, we can figure out the range. From lowest to highest, the range goes from what to what? Michael? No, the closer one. All right. It has to be the y values in this case. There we go. 0 to infinity. All right. That's all right. 0 to infinity. And let me make that actually look like a bracket. There we go. 0 to infinity. But notice that the domain actually matched what we expected from negative 2 to infinity. It's everything to the right of negative 2 and including negative 2. So greater than or equal to negative 2 or negative 2 with brackets to infinity. Now some of these graphs are more difficult to visualize, and so you kind of really want to use something like Desmos or a graphing calculator. And I'm going to help you out with the next one, and I want to show you a little trick too. So hopefully this video is well done and gets posted on YouTube so that you can review this if and when needed. But our next graph is this function, y equals negative the square root of 25 minus x squared. And kind of like the last one, we're going to have problems when 25 minus x squared is less than 0. So we want to ensure that 25 minus x squared is greater than or equal to 0. And it's stuff from section 1.8 that discusses how you solve that. But really this can only be true as long as the values of x are between negative 5 to 5. and that's what's called, or that's what's going to be our domain in this case, -5 to 5. If you were to square this equation and move everything to the left-hand side except the 25, then what you'll see is, where this graph gets its shape. But unless you know that, or know to do that, you might not know what this graph looks like. So let's start by entering this into our graphing calculator. Clear out the graph that's there. Start with the opposite key next to the decimal point. Then second square root 25 minus x. I always hit the square key on the left-hand side of the calculator to get my x squared, something like that. There's my function. But I have to tell it where to graph this thing. So here's where we're going to let our calculator do some of the work for us. So everyone got the function entered. Courtney's helping out, somebody? All right. All good on the function. Let's go over to the window. Hit the window key. And type in -5 to 5 on the x's. The problem is we don't know what the y value should be. So, But there's good news. We don't have to figure out what the y values are. We can let the calculator worry about that. So everyone's got the -5 to 5 here on the window? Maha? Okay. So hit the zoom key, and you don't even have to see it. But I'll just show it to you. Zoom 0 is zoom fit. It's going to adjust your y-axis so that you can see all the values of y that you need for the values of x that you gave it. So hit zoom and then type 0, and it should fit things, and you should get something that looks like this. Yay. Now, for a lot of you, that might look like kind of like a parabola or something like that. It's really not. But the zoom fit is a good key to use. So are you comfortable with that much? Let me show you just one other thing. Not that you need to know it, but it'll help you identify what this looks like. If you hit zoom 5, that is zoom square, it'll square things up. And now you can kind of see what this looks like. It's really the bottom half of a circle is what this graph is. So a circle of radius 5. There's your graph. And now that we have the graph, we've got our domain, -5 to 5. What about the range? What would the range of this function be? Not -5 to 5, -5 to 0. Is 0 going to get a bracket or parenthesis? Well, let's hit the trace key and type in the number 5. So 5 is my x-coordinate. What do I get for the y-coordinate? 0. So it actually does get up to 0, doesn't it? So -5 to 0. There's your x and y coordinates. So it gets up to 0, and that's the top end of your range. Yay. Are you getting comfortable with domain and range? And hopefully you're getting a little bit of a comfort level with the graphing calculator. This is the 21st century. All right, we need to use some technology here. One of my coworkers does not use technology when doing statistics, and I find that very distressing. So, all right, let's do a few more here. We will eventually get to problem 44. Right now, we're going to look at problem number 24, which is kind of a two-parter. Yeah, we are going to look at desmos on this. Let me write it up here first, and then I'll switch over to desmos. So problem 24 gives us -2x plus 3 equals 3x minus 7. This is just a linear equation. It'd be really easy to solve this thing. But we're going to start getting comfortable with technology in solving this. So part A is to solve this one. Part B, we want to know where this one is bigger than this one. So let's see. Let me just double check that. I'm pretty sure that's what they're looking for. For some reason, I'm on the wrong page. Yeah, which is equivalent to what I had said. There. So we want to know where this one is bigger than this one. One way to figure this out, to answer this question, is to say, all right, I'm going to graph y equals this and y equals this, and find out where those two graphs cross each other. Because really what you're looking for is where these two things are equal. So let's do that. And that's on Desmos for us. Now I sent you an updated link right before class. So if you're there, great. One thing you might want to do for yourself is click the tool icon in the upper right hand corner and click on the projector mode. That makes it a little bit easier to see. Let's see, I'll show you with it off. It's just not as bold and vivid. I like it with projector mode. So we'll keep it there. And let's turn on both of these. And you can see that they cross each other. You can take and click and drag. So you can see where they cross each other. They cross each other at the point 2, -1. But we're looking for the value of x, where they cross each other. And so that's going to be at x equal 2. So that's your solution to the first part, is x equal 2. And you can just solve this. You get the exact same thing. There's nothing wrong with that. But the idea is to start associating the graph of these equations with the solution. So we can get the solution that way. Now for this second part, I want to know where this graph is bigger than this graph. So where is this line taller or bigger in the y direction than the other line? So again, let's go back to Desmos. And we can kind of see it here, right? I want the green line to be bigger than the blue line. Is that going to happen to the right of 2 or to the left of 2? To the right of 2. So I want everything to the right of 2. Now, am I going to include 2? Is that going to be part of my answer? Yeah. Because I'm looking for this to be greater than or equal to. So I can actually include 2 because that's where they're actually equal. So my answer on this one should be 2 to infinity. So 2 to infinity. And that 2 gets a bracket. My brackets are off today. Now for giggles, let me show you what Desmos would do if I just type that in. So what Desmos is going to do is it's going to graph x values of x greater than or equal to 2. And so you're going to see exactly that. Kind of overkill, really, because all we need is 2 to infinity. It graphs this entire half plane, but that's okay. It's still showing you effectively the same thing. 2 to infinity is where that's true. How are we looking on problem number 24? Okay there? Let's try that again with problem number 26. Some different functions here. So problem 26, we first want to solve negative x squared equals 3 minus 4x. We're going to do that in a couple different ways. One way to do that is simply by graphing it. So that is, we're going to graph y equals negative x squared and y equals 3 minus 4x. But let's actually just solve it regularly. If you were to solve it like you did in your Math 1150 class, then you'd probably do something like this. You'd move the x squared to the other side and rearrange the equation. How does this factor? All right, x minus 3 and x minus 1. Thank you. Angel, what are solutions to this particular one? What value of x would I plug in here to make this 0? So, yeah, 3 and 1. 3 and 1. So that's what we should see when we graph this, is that these two graphs should intersect each other at those points. Let's see if that actually happens. Now, some of this might be a little bit of overkill in terms of solving this equation this way, but it's a matter of getting used to these graphs. So let's shut off these ones here and turn on the next set. So down here, problem 26. And I'm going to adjust the graph here a little bit so that it shows up a little bit better. And let's see, the settings I want to use. Let's see, go to Tools here. On the y-axis, I want to go down to, let's go to negative 35. Well, let's see, does that take it out of focus? No, we're okay there. So negative 35, that should be pretty good. We can see where they cross. There's a point at x equal 1 and a point at x equal 3. So, yay. Nice. Now, let's go down and work with the next question. We want to know, where is the value of negative x squared greater than or equal to the value of 3x minus 4? So which graph am I looking to be on top? I'm looking for the red graph to be on top or the blue graph to be on top. Well, so this would be the red graph down here. So that's really part B, and I should probably make that a little bit more clear as we're moving on to B. We can actually see our answer for part A graphically if I click this. And notice what it's giving me. It's giving me these two values, right? Right here at x equal 1 and x equal 3. So those are my two solutions for part A. Part B asks us for the solutions here. So let me write that down as our part B. So I want to find negative x squared is greater than or equal to 3 minus 4x. So that's the second part of this. Where is that true? So I've got a couple people volunteering some answers. That's good. And one more time. Do I want the red graph on top or do I want the blue graph on top? Red graph on top. Good, because that's your parabola. That's your negative x squared graph. And that's going to be on top for what values of x? Just 1 and 3? Yeah, 1 through 3. So the interval 1 to 3. So the interval 1 to 3. Ah, well done. You anticipated me. Brackets. We want brackets on that one because we're including the endpoints. If you did that one on desmos, then it would show you the same thing. So let's click down here for the last one. And notice that it's highlighting everything between 1 and 3. That's your answer. So it's telling you the same thing that we figured out for ourselves. But at least it's reassuring there. How are we looking on 26? Is there anything that I could add some more detail to in problem 26? So we got part A right here, and our answer for part B is down here. Okay, so it's a long. This is a long section here, so I'm going to kind of mix things up a little bit. So if you're watching this at home and you're like, oh no, I just want the meat and potatoes, that's fine. But let me just give you a little bit of a break here and ask you a couple questions and let you know that math culture is actually more part of your culture than you realize. What's people's favorite search engine? Google. But that's actually a math term. They borrowed it from a math term. Google, G-O-G-O-L, is a 1 followed by 100 zeros. So it's a really, really big number because the number of particles in the universe, electrons, protons, neutrons, is thought to be around 10 to the 80th power. So it's a really, really huge number. Certainly much more than we can find an application for. But it does have other uses, like in The Simpsons and Futurama. Now, a little bit of maybe an anachronism here for us. A multiplex used to be the name that they would call theaters with a lot of different, little theaters in there. So theaters 1 through 12. I think Showcase had 1 through 30 for a while, but it's called a multiplex. If you take the idea of a Google and amp it up a little bit, what if you had not 1 to the 100th power, but 1 to the Google power, Googleplex. So a Googleplex. So a Googleplex is 1 to the power of a Google, which is beyond imagining. I just can't imagine something that big. Yeah, it's a Googleplex. So it's used in, well, a Google is 1 to the 100th power, or 10 to the 100th power, and a Google is 10 to the power of a Googleplex is 10 to the power of a Google. Let's see. So not that one. Google search, Googleplex. They use it in Futurama. And why isn't this going over here? Googleplex, Futurama. They have a Googleplex. Hey, so their theaters are a Googleplex. So kind of cute. And at LA Fitness one time, I saw a guy with that license plate. So, yeah, kind of wonder what he does for a living or she does for a living, that they would have that license plate, Googleplex. Yeah, I didn't really tend to do a selfie there, but I guess I kind of did. So, anyways, a little something about Google and Googleplex there for you. Kind of give you a little bit of a break as we go through section 2.3. But let's get back to it. Let's get back to the stuff with desmos and 2.3. Oh, so there's your circle from problem number 22. So the negative one was the bottom half. The positive one would be the top half of the circle. So you can graph it that way. Let's continue to do some work with the graphing calculator. Take a look. I think we're going to do problem number 30 next. No, here. All right, so I'm going to shut these off, and let's kick on to problem 30. Problem 30 is going to ask us to work with these two graphs. And I'll probably need to change the window here a little bit. Let's make that from negative 3 to 3 on the x-axis and negative 1 to 3 on the y-axis. There, something like that. Yeah, no, I was going to write it down. Just let me flip over to the right screen here. And we're going to have two problems that we're going to solve in conjunction with problem number 30. Part A is to decide where 1 plus the square root of x equals the square root of x squared plus 1. So that's part A. Separate but related to that is part B, where we want to find where 1 plus the square root of x is greater than the square root of x squared plus 1. So those are the two parts of the problem. You could also do this on your graphing calculator. I would set up kind of a similar window to what we've done if you can do it on your graphing calculator. Maybe we should practice it on our graphing calculator. Let's do it that way. We can see off of desmos when we're all done that they're equal. So on the graphing calculator, let's first start by entering in the two equations. So we'll start by pressing the y equals key and clearing out all the stuff that's there. You can use the up and down arrows to clear out that stuff. The first equation is going to be 1 plus the square root of x. Square root key is above the squared key, so you have to hit the second key, then the square root key, and then type in the x right here. Second equation is the square root of 1 plus x. And this time hit the squared key right above the log key, 1 plus x squared. You should have both of those entered like that. So I'll pause for a second to make sure everyone's got the functions entered. Yeah, I have to be careful about how I ask calculator questions on an exam, but I'd be comfortable asking one like this because your work isn't just a little bit. I mean, there's a few things to do. So yeah, I'll be careful, and in particular, I'll have to tell you where I want you to round your answer. I think the book asks us to round our answer in this case to the nearest 100th place. Usually I go 1,000th or 10,000th, so third or fourth decimal place, but it's just going to depend on the problem. Are we good with entering in the functions? Let's set up our window, and we'll go from -3 to 3 on the x-axis, and from, say, -1 to, I'm thinking, we'll just go 5. Should work on the y-axis. When you've got those settings adjusted, hit the graph key, upper right. So there's our first function, and here's our second function. Yay. So what we want to do is we want to figure out where these two things overlap, where they intersect. Now I'll give you a freebie. In fact, you can kind of see the freebie. What's one point where these things overlap? Well, be careful. It's a 1 for y, but 0 for x. So we want to answer in terms of x. So it'd be 0 for x, but the other one's tough to see, isn't it? The other one's like, well, I don't know, it's around 2, but it's not exactly easy to see. So this is what you want to do. You want to find that point by using the technology in front of you. Hit the second key, then the calculate button. Does there look like something there that might be helpful? I'm saying second key, then it's the trace key that takes you to the calculate menu, though. So yeah, the fifth option down is going to help us find the intersection. So either type the number 5 or cursor down and press enter on 5. But either way, you should get something like this. So I want to keep us all together. We're all here, right? Yes? All right. So sympathetic nods. It's going to try and ask us where we're going to look for an intersection. So let's get at least a little bit closer to that point of intersection. So notice that I'm on my first curve, and you can see that up here. It says, oh, you're on this one, 1 plus the square root of x. So I'll get somewhat close, and you don't have to be right on top of the intersection. And I'll press the enter key. And now it puts me on my second curve. And it says, all right, well, give me a value somewhat close on the second curve. All right? So you can just press enter again if you want to. You don't have to get terribly close. And then it's going to ask you for an initial guess. And having studied numerical analysis, I can appreciate why it's doing that. But mostly I find this annoying for you and the students, or you as students. Press enter again, and it's going to think for a second, and then it's going to calculate that point of intersection. What is that point of intersection? Yeah, it's right down here. 2.31, et cetera, et cetera, et cetera. So if the book's asking you to find that point of intersection rounded to the nearest hundredth, it'd be about 2.31. So we've got two solutions. 0, which we can kind of look at and see, and then this one, 2.31. So x equals 0, and x equal 2.31. And I should probably put approximately. Say again? It depends on the window, and the window is not necessarily going to be accurate enough to get to the nearest hundredth. Because if I trace around, I mean, look, if I chase around a little bit, you know, it's tough to tell if I'm at that point or if I'm close to that point. So I would go with the calculate approach. I mean, tracing can get you very close, and if you're good, you can probably get all the digits that you need, but you have to keep on increasing the zoom on your window. I could ask for anything. I mean, really? Did you type in the functions correctly?
I mean, I have when I do it this way with the enter 3 times.
I'd have to look at that. I mean, it should. I mean, there really should only be one answer here, and that's the 2.31, etc. Let's just double check it with desmos. So the nice thing about desmos is that when you click on these points of intersection, it'll tell you. And so I'm pretty comfortable with our answer. So let me see your calculator after class or something like that, and we'll see what we're getting. But it shouldn't be off at all. It should be exactly the same thing that I'm getting right here. Let's see. The intersection. So intersect, bam, bam, bam. You should get exactly the same thing. 2.31459, etc. If you accidentally hit the trace button, maybe you moved it. Not sure. Are we okay with our answers here and here, 0 and 2.31? The second part of this is that we want to know, where is this graph bigger than this graph? Now, it's helpful to kind of keep things in perspective here. And your graphing calculator, especially the ones that I'm loaning out people, is really nice because this curve is the red curve. It says, all right, that one's this equation. If you hit the up arrow key, it's going to jump to the other equation. So we know the blue one is 1 plus the square root of x, and the red one is 1 plus the square root of 1 plus x squared. I want to know where the blue one is bigger than the red one. Where is that true? Where does that start? And where does it kind of end? 0 to 2.31. So 0 to 2.31. How come I'm using parentheses here? Right. Yeah, it's just greater than. It's not greater than or equal to. If it was greater than or equal to, then I'd use brackets. It's not, so I'm just going to use parentheses there. All right. Thank you. How are we looking at number 30 there? You mean yours doesn't? Boy. I'd have to double check that. It should. When you hit the trace key, it should show you the label.
That's okay. It just, oh, actually, you know what? It just labels Y1, Y2. That's fine. That'll be good enough, I guess.
Okay, but it should show you the coordinates on the bottom too, though.
The coordinates it will, not the actual function name.
That's odd. All right, let's look back at our handout, see where we're at. So we've done 32 and 34. Let's move up to problem number 44. 44 is going to ask us to learn something else, which is minimums and maximums, local mins and local max. You can see that on page 176 if you happen to have your book open. You don't have to. You can just look up here real quick. Local maximum is something that's bigger than the points near it. It's king of the mountain. So these two are KOMs. These two are minimums. So they're smaller than anything near it. Now we emphasize near it because this function could continue to go down forever, in which case this would no longer be, a minimum. It's a local minimum, but it's not what's called a global minimum. And likewise, this could keep on going up and up and up. This would no longer be the maximum, but it's maximum to any point nearby. So they're local mins and local maxes. So that's what we're going to limit ourselves to, is local mins and local maxes. And with that, let's take a look at problem number 44. And I can ask several things here. I can ask for the local max, the local min. And when I do that, I'm looking for the x-coordinates of the local max and local min. And let's also work on where it's increasing and decreasing. So how about this first point? Good. Now, as far as the local max is concerned, I have to be careful, and so do you, about what's being asked for. In this particular case, I believe they're just asking for the x-coordinates, so it'd be -2 would be the x-coordinate of that local max. We've also got another local max. Yeah, at 2. So -2 and 2 are the local maxes. Where's the local min? Yeah, x equals 0 is the local minimum. Now that's where it is. What the local min is or what the local max is would be your y-coordinate. So it depends on what's being asked for. And like I said, I promise I'll be very clear and careful about what I'm asking for. If I'm asking for the x-coordinate or the y-coordinate, typically speaking, it's going to be the x-coordinate. Now, the nice thing about identifying the local mins and maxes is that helps divvy up where it's increasing and decreasing. So give yourself a minute and try and figure out where it's increasing and decreasing. Okay, so let's take a look here. This point is at -2, and what's happening to the function until we get to this point? So, say from here to -2, what's the function doing? It's increasing. So, from -infinity to -2, so -infinity to -2, and after that, well, the function starts decreasing, and it's decreasing until it gets to 0. So that'd be between -2 and 0. Again, keep in mind that these are intervals along the x-axis. And then a short little brief increase again, right? 0 to 2. 0 to 2. And finally, what happens to the function after that? Decreases. 2 to infinity. Thank you. 2 to infinity. So a lot of information we can get off of our graphs. Are we okay with problem 44 here? Let's look at something like problem number 44, except on our graphing calculators. That's going to be the last problem for this section, which is problem 48. So we'll start by entering in the function f of x is 3 plus x squared minus x cubed into our graphing calculator. And then we're going to look at it with 3 different windows before we're going to start answering some of the questions here. So let's enter this into our calculator using the y equals key. Pressing that there, I'll clear out the stuff that's here. So 3 plus x squared minus x cubed. Remember to get that cubed. It's going to be x raised, which is right above the division key, to the 3rd power. And you press the enter key. Now, if this is your first time graphing this, you might not know. It's like, oh my God, where should I graph it? So we're going to look at 3 different graphs, and my goal here is just to try and get you a little bit more comfortable with moving around in your window, trying to get a better and better graph. But do we all have the function entered? Good, got it entered? All right. So one kind of approach is kind of like a shotgun approach. Just like, all right, let's just throw a big wide pattern out there. Go from -10 to 10 on both the x and y axes. And you can do that at a push of a button. It's zoom standard. So zoom 6. So the zoom menu is up here. Zoom 6. And that'll graph it from -10 to 10. Okay, it's your first look at the graph, just to kind of see where it's at. Now, when I look at this graph, I see, you know what? There's a lot of wasted space here. So, in particular, I really don't need to see the graph to the left of -2 or to the right of, say, +3. So let me go back and adjust my window. Now that I got a better look at this graph, let's go from -2 to 3, and then hit graph again. And that's a better looking graph. It's a much better looking graph. Kind of zooming in on what's important for this graph. If I wanted to make one more change, I might throw out a little bit of it on the bottom and a little bit on the top. So I could go from, say, -7 to 7. And I'm kind of zooming in. I'm getting a better picture. And I can see that this graph snakes around a little bit. It's decreasing, then increasing, and then decreasing. And so what we're going to need to find are the local min and the local max right here. You should have a graph that looks something like mine. It doesn't have to be exactly like mine right now. What we want to find next is this point. Where is this happening? So press the second key, then the calculate menu again, or second and then trace. If I wanted to find the minimum, then I'll take the third option down, minimum. Now your calculator is asking you to figure out, well, where am I looking for the minimum? It wants you to tell it that. So you need to tell it the left bound. So you want to go past the minimum, someplace a little bit to the left of the minimum, and then press the enter key. So go to the left of your minimum using the left arrow. And when you get to some point that's comfortably to the left of that, press enter. And then it's going to ask you for a right bound. Where's the right bound? Go to the right here. And press enter. Let's see, I might have screwed up a little bit. Let's see. And then after you get a left bound and a right bound, you should have a couple arrows that are facing in. It's going to say, all right, give me your initial guess. Where do you guess that minimum is? You can just press enter if you want. It'll be fine. But it should give you a minimum that looks like it's at about -1/3. You guys getting that value? No? Yes? No? Some are, some aren't. Tell you what, we'll try it again with the maximum over here. So you can kind of practice along there. So the minimum, min is at x equals -0.3333. I'm pretty sure it'd be exactly -1/3 if we weren't using a calculator, if we were using, say, methods of calculus. And let's figure out where the maximum is. So let's do the same thing to try and find the maximum. Hit the second key, then the trace key. This time we want to find the maximum. So cursor to the right a little bit until you get someplace a little bit to the left of your maximum, because it's going to ask for the left bound and then the right bound. So I need a point to the left of the maximum. So I'll press enter here, and you can have a different right bound, that's fine, or a different left bound. Doesn't have to match mine exactly. So I've got a right bound and a left bound. And then, you know what, just press enter one more time, because it wants an initial guess. What would that value be for x if you round it to like anything reasonable? 1. So 1 is your maximum. So maximum is x equals 1.0000. So there's your min and then your max. With your min and max established, now we can figure out where it's decreasing and where it's increasing. So it's decreasing from -infinity to -1/3. Decreasing -infinity to -1/3, and from 1 to infinity, comma, infinity. And it's increasing in between. So from -1/3 to 1 is where it's increasing. Whew. All right, well done. For homework, try 7 through 37, 43 through 51, 55, and 57.